Today we can start the discussion on the new thermodynamic term enthalpy, indicated by the letter H. What's the purpose of the introduction of this new enthalpy term in thermodynamics? There is a specific reason. As you studied from the significance of internal energy, you know that delta U is equal to QV. That means internal energy change, that it is equal to the heat change at constant volume. So at constant volume, at that condition only the internal energy change, that is equal to the heat change. But you know that most of the chemical reactions, when it is carried out, there is a volume change, it will be occurring. So just imagine this is a one beaker and here we are doing one chemical reaction. So two components A and B, it's there. So here one chemical reaction it is going on. So this chemical reaction normally we are taking at constant pressure condition. That means atmospheric pressure at that time. On the base of that we are doing almost all the chemical reactions. So due to the chemical reaction there is a chance of changing the volume of the components, the product after the reaction. So the most of the chemical reaction it is carried out at constant pressure, and there is a if it is carried out like that, there is a chance of changing the volume. So as you studied earlier, delta U is equal to QV, that it's not applicable in some situations. Why? Here constant volume, that it is not maintaining over the reaction. So instead of this, the new enthalpy term it is introduced on the basis of at constant pressure what it is happening. At constant pressure what it is equivalent to the heat change. For in the introduction of that term, the new enthalpy term it is introduced as a state function. Enthalpy also it is considered as a state function. Now just think about that, what it is enthalpy. Enthalpy it is the sum of the internal energy and the pressure volume energy of a system. The sum of U is the internal energy, P is the pressure, V is the volume. So internal energy plus what's the energy in that system, along with that you have to be add the pressure volume energy of that system also. Altogether you will get a new thermodynamic term, that it is enthalpy, indicated by the letter H. Okay, so enthalpy, there is a one more name we are introducing, one more term we are telling for this same enthalpy, that it is heat content. So H, heat content, enthalpy, all indicated by the same meaning. Now we can discuss on the significance of enthalpy change. Always you know that enthalpy change it is indicated by this delta symbol. So delta H it is said to be the enthalpy change. What's the importance of delta H? You studied that H is equal to U plus PV. So here some mathematical expressions it is needed. So delta H means the whole we are multiplying with the delta. So what it is happening here? Delta H is equal to delta of U plus PV. So you know that delta U plus delta of PV. So that's equal to delta U plus delta P plus, delta P into V plus V into delta P. Likewise the derivation it is coming. So for explaining this significance of enthalpy change, the system is undergoing the chemical reactions at constant pressure. Right? If it is a constant pressure, you can see that the delta P, the change it should be the 0. So as we discussed, the derivation of delta H is equal to delta U plus P into delta V plus V into delta P. When delta P it is equal to 0, because the reaction we carried out at constant pressure. At constant pressure, what is the heat content value that we are going to be do with this enthalpy? Right? So for that we took this chemical reaction at constant pressure. So delta P if it is equal to 0, this term into 0 here it comes for this delta P. So V into 0, this term it will be cancelled. So what it is remaining? Delta H is equal to delta U plus P delta V. This it is cancelled. So the reaction it is delta H is equal to delta U plus P P delta V. It is very important chemical equation. Then this is derivation part now. So for that we took the first law of thermodynamics. You studied that delta U is equal to Q plus W. So this Q plus W value you just introduce at the place of this equation. So here delta H is equal to Q plus W plus P delta V. But W also you studied in the first law of thermodynamics, that it is equal to minus P delta V. That also you introduce here. So here delta U is equal to Q plus W, W is equal to minus P delta V. So delta U is equal to Q plus minus P delta V, it is coming. So delta U is equal to Q minus P delta V. So this Q delta U value just introduce in this equation. So what will be happening here? What will be happening here? Delta H is equal to delta U, it is equal to, you got it here. Yes, Q minus P delta V. Then P delta V value also here. That also you have to be write it here. So minus P delta V plus delta V cancel each other. So what will be happening here? Delta H is equal to Q. Q at what condition we got it? At constant pressure. So what is our target to get the heat content? At constant pressure. What's the state function? So that state function, it is equal to delta H, that is an enthalpy change. So enthalpy change, it is equal to the heat change at constant pressure. And just before you studied significance of internal energy, from that delta U is equal to QV, that is the heat change at constant volume, it is equal to the internal energy change. Don't confuse. One is enthalpy change, one is entropy change. Enthalpy change, it is equal to the heat change at constant pressure, and internal energy change, it is equal to the heat change at constant volume. Then one more derivation we have to be discussed here, the relation between delta H and delta U, internal energy change and also enthalpy change. Is there any relationship? Right. So here we studied that most of the chemical reaction is carried out at constant pressure, and most probably after the chemical reaction there is a chance of the volume change. Just assume there is no volume change after the chemical reaction. The same volume of the product we got it. Just assume like that. So there is no volume change. So just assume such a condition. So delta V is equal to 0. Okay. Pressure at constant pressure we are doing. So delta P also equal to 0. Such a condition we are assuming now. Yes. So the equation you know that delta H is equal to delta U plus P delta V. If delta V it is equal to 0, this term completely cancel each other. So delta H it is equal to delta U. That is enthalpy change, it is equal to the internal energy change. Then enthalpy term you know that delta H it is equal to QP and delta U is equal to QV. So if delta H equal to delta U, automatically QP is equal to, here QV. QP is equal to QV. Okay. So there is a relationship between this enthalpy change and internal energy change. Now we can discuss about solid, liquid, gases, the chemical reactions. When you take the chemical reactions for this at constant pressure, the volume change. So if it is a solid, here you taken the components. After the reaction also, there is not such a change in the volume. So this condition it is favorable for the case of solid as well as liquid also. Liquid's case also the same situation. After the chemical reaction, not so much change we are seeing in the case of volume. But in the case of gases, there is a volume change, it will be there. So that time delta H it is not equal to delta U. Consider the chemical reaction. Here in this chemical reactions we are mainly involved with the components as gases. So when such a chemical reactions, if it is taking place, the volume change it will be there. So in such a situations, when we carried out that chemical reactions at constant temperature and pressure, there is a mathematical relationship also we can prove. We studied that the ideal gas equation, that it is equal to PV is equal to nRT. On the base of this equation we are doing this mathematical relationship. Here PV is equal to nRT, that you will study in the chapter the states of matter. So just assume the volume of gaseous reactants. So at the beginning, how much reactants we taken, that reactants volume you just take it as V1, and the number of moles we taken it as N1. So after the process you will get the product's volume, you just imagine it as V2, and the number of moles of the product it is N2. So as you studied early, PV is equal to nRT, that relationship. On the base of this relationship, P is the pressure, V is the volume, N is the number of moles, R is the gaseous constant, and T is the temperature. Right? So here we can apply the same situation here in this equation. So here PV1, we took this chemical reactions at constant temperature and constant pressure. So rest all conditions it will be changed. So temperature term and pressure term it want to be the same. P and T it want to be same, and R also will be same because R is a constant value 8.314. Likewise one value it is. So that you will get from the chapter states of matter. Okay, so there is a change, it will be happen only in the case of V and N, that is volume and number of moles. Right? So what is the thing we are writing here? P R T, you keep it as a constant value. So PV1 it is equal to N1 RT. Okay, then this is the reactance case. Then product case, what about that? PV2 is equal to N2 RT. Then just subtract it. PV2 minus P1 is equal to N2 minus N1 minus N2 RT minus N1 RT. N2 RT minus N1 RT. So P common it is here. So V2 minus V1 you take it out. Here also the same RT it is common. So RT you take it out and N2 minus N1. So V2 minus V1 that you can, it is a change. So you can write it as delta V, and N2 minus N1 that is also change. You can write it as delta N. So P delta V is equal to delta N RT. Such a relationship also you can make it from this the same. Here delta N it is equal to N2 minus N1, that is number of moles of products minus number of moles of reactants. We consider all these changes on the base of the gaseous reactions, because delta H value not equal to delta U. On the base of that only we created everything. So just apply P delta V value, you got it as delta nRT. Then in the equation you studied that delta H is equal to delta U plus P delta V. Such a enthalpy change reaction you studied, P delta V. Here P delta V, instead of this you just apply this value. So here the equation change as delta H is equal to delta U plus delta N RT. Right? Then delta H and delta U, you studied that delta H is equal to QP and delta U is equal to QV. Likewise also you can substitute here. So QP is equal to QV plus delta N RT. So a lot of chemical relationships you can get it from this enthalpy change portion. What's the first equation you studied? H is equal to U plus PV. So from that delta you make it. So on the base of that delta is H is equal to delta U plus P delta V. Very important reaction. So after that delta H is equal to Q P you studied. Then afterwards you studied that the relationship between these two. How it comes. At constant volume when the reaction if it is carried out, what will be happen. So that time then in the case of gaseous reactions it will not be applicable. So afterwards we find out that what's the change in that gaseous reactions. P delta V value you found out, and on the base of that you created two more equations. So a lot of equations here in this contest. So you have to be study well these portions. Okay, thank you.